Here we are going to see the subject analog and digital communication. For that, this is going to be the first lecture where we'll discuss what is the basic blocks of the communication system and how each and every block is going to play the role, as well as what is the modulation, what are the importance, and what is the need of modulation that we are going to see. And first of all, we have different types of the way of communication that we are going to see. So still you didn't subscribe our channel, please subscribe it and share with your friend. If we talk about on the basis of what are the various ways, okay, to communicate. First of all, we'll see what is the communication. So when we're trying to exchange the information, that is called as the communication. And information means the signal consists of some information, or the signal is the source of information, okay, which has some meaningful information. Sometimes noise also going to appear. So on the basis of way of communication, we have first one is the simplex. So in the simplex, the communication is possible in only one way. Like here, if you see that sender can send to receiver, but receiver can't send back again. Next, we have second type is called as the duplex. So in the duplex, communication from the both side is possible. So here duplex is divided into two parts. One is the half duplex, another is the full duplex. In the half duplex, both sides can communicate, but at a time, only one side can communicate. Later we'll see the difference. In full duplex, both sides can communicate at the same time. Like here, if you see that sending, receiver, again, receiver is also going to act as the sender and sender become the receiver. Okay, so now what is the basic difference here? So simplex is what? One-way communication. The data flow is also in one direction. One of the example is from the keyboard to CPU. When we are going to give some information with the help of keyboard, on the basis of that, CPU is going to receive. In case of half duplex, it is the two-way communication, but at a time, only one side can communicate. Example is the walkie-talkie. In case of full duplex, both sides can communicate simultaneously. So that example is our mobile phone, telephone, all these things. Okay. So if you see here, types of communications, on the basis of that, we have difference here in this table also. Simplex unidirectional, half duplex bidirectional, full duplex again bidirectional, but in half duplex one at a time, full duplex simultaneously. And main importance part is here, performance wise, simplex is the least, half duplex is the better, and full duplex is the best. And advantage one upon others, that in case of simplex, it is going to utilize the entire capacity and maximum bandwidth is being used here. Whereas if we talk in terms of half duplex, so here since communication is possible both sides, but only one at a time. So it's going to conserve the bandwidth and it is going to utilize a single communication channel. But in case of full duplex, both can communicate simultaneously. So finally here, that both direction communication is possible. So delay is less, or almost. It depends upon the which type of like 4G, 5G, 6G, what we are using. On the basis of that, delay will be reduced. So this is the basics about types of the communication. Next, we are going to see that basic building blocks of the communication system. On the basis of that, we'll discuss. Now here we have in communication system, basic important thing is what is the basic building blocks of the communication. So in the building blocks of the communication, we have transmitter, then we have channel. So this channel can be wired, it can be wireless. And next third block is the receiver. So this receiver here, when it is going to, it is like full duplex communication or simply duplex also, then receiver will become transmitter and transmitter will become the receiver. So this channel can be wired or wireless. For the long distance communication, we use the wireless channel. For the internal communication, like LAN connection, all this, we can use the wired connection. So in the communication, finally, what we are doing here, sending the information, receiving and processing of information by the help of electronic devices takes place. So here, if you see the detailed diagram of this, here we have source of information. It can be recorded source. It can be the message source that is given to the transmitter here. So in the transmitter section, modulation takes place. So modulation is the process in which carrier signal is going to change according to the instantaneous value of the message signal that we'll see in detail later. Then this modulated signal is being transmitted. So this is the outcome of this transmitter is given to the antenna. Then with the help of antenna, it is being transmitted. So whatever we are transmitting here, that is here modulated signal. So that modulated signal having, so generally we represent with the help of S of T. It has message with carrier, okay? And it is given to the channel. Then we have receiver part. So in the receiver, demodulation takes place. So that extraction of the message information takes place from the received signal. So that carrier part will be separated and we can have our original message signal. And finally, it is given to the users or where information is required. So in case of when we'll talk about what is the information, this is the signals which having some informations. So sometimes we have like we are using the microphone when we are talking about live signals, or we can have some recorded version of this. Okay, so that is having some information that we want to convey to others. So that amount of the information is being measured. If you talk about digital communication, that is measured in the bits. Since when you are going to store anything in the information, it is in the bits only. Okay, so that's why that memory will be given in the bits. So 4 bits is equal to 1 nibble. Okay, and 8 bits equal to 1 byte. So that is the way we are going to treat the information. Next, we have transmitter. So transmitter is connected with another block diagrams that we'll see, where we have oscillators that generate the carrier signals, and here modulation of the signal takes place. So before transmission, modulation will takes place with the help of suitable method that we'll discuss. And this process here, and the signals is being encoded. If you talk about the digital communications, that is signals is being decoded, encoded, all those encoder decoder sections are there. And information is being with the help of carriers, it is being transmitted where carriers are going to change according to instantaneous value of the information. So we have various modulation techniques, like we have amplitude modulation, frequency modulations, and phase modulation. So frequency modulation and phase modulation is the part of the angle modulation. And amplitude modulation is also called as the linear modulation. Here we are going to talk about the DSB, SC, SSB, all these things. Next we have noise. So when we going to transmit, even sometimes device is going to also generate the noise, like we have Johnson noise, thermal noise, all these things. So signal with some some distortion takes place. Distorted signals we are going to receive, and in that distortion is due to the noise. Noise is what? It is the unwanted signals, unwanted energy that is going to mix with the our transmitted signals. So that noise is going to interface our signal, and for that we can use the filters. Different types of the filters are there. As per the signals, we can use that filter. Then in the receiver section, if you see, so receiver will start with the antenna. Okay, so later we'll see that we have very popular super heterodyne receiver. That is also one of the important question. Here, one question, if they're talking, easy question is going to come, they will ask about this, describe about the building blocks or basic blocks of the communication system. Otherwise, objective question also, you have about the basic blocks of the communication system. So again, which type of the receiver we are going to use depends upon the which type of the modulator is used. On the basis of that, we have different types of the demodulators in the receiver section. Now, one of the best receiver is the super heterodyne receiver. So that some blocks of super heterodyne receiver is shown here. So we have antenna is given to the RF stage, and here we have mixture and local oscillators. So that local oscillator frequency is much higher than the message frequency. So that FC is much higher than FM. So FM is the message frequency. After that, we have intermediate frequency amplifier that we call as the IF amplifier. Then this is the demodulator sections. And finally here, audio and video part is being separated and transmission will take place. For that, we have power amplifier. And this is the loudspeaker. Or simply want audio signal only. So speaker is sufficient. Otherwise, for the video, display is required. So that what we are trying to do here, that transmitter and receiver must be synchronized. Means when transmitter is ready to transmit, receiver should ready to receive. Okay. So that, or sometimes we are trying to see that same carrier frequency should be used in the both transmitter section as well as receiver section. And corresponding what modulator we are using, corresponding demodulator should be used. Now, very important question is the modulation. What is the modulation? What is the need of modulation? Short questions or sometimes 5 marks question also there. So in this process, generally, like we are going to superimpose the low frequency component over the high frequency components. So carrier signal is the high frequency component. Message signal is the low frequency components which having frequency FM and FC. Suppose, for example, it is 100 Hertz. So maybe carrier signal will be 1 kilohertz, or if your message signal is 1 kilohertz, carrier signal will be 10, 100 kilohertz like this. So generally the characteristics of the many times students get confused. So which signal is changing? Carrier signal. Since message signal having information, we don't want to lose the information. So carrier signal is going to change according to the message signal, according to the instantaneous value of the message signal, that is called as the modulation. We'll see with the help of waveform also. So what is the need of the modulation? So it is need in order to match the characteristics of the input signal so that it will have similar channel characteristics. And multiplexing is possible. Multiple signals we can transmit together. Like we have frequency division multiplexing, we have time division multiplexing. And what is the basic concept of the multiplexers? When we have multiple inputs, with the help of single output, we are able to send. Okay. So like to the power n cross 1 multiplexer, you are aware in the digital electronics. So here we have frequency division multiplexers and time division multiplexers. And next we have wireless transmission of low pass signal is possible with the help of modulation, and it's going to reduce the effect of the noise on the signal also, and as well as modulation techniques are power efficient. So these are the basics requirements of the modulation. That's why modulation is required. Now we'll see with the help of diagram how various modulation takes place. Quick diagram we can see. Later in detail again we'll see different types of the modulation techniques, how signals are being generated, and again how it will be detected. Here you will see that this is our message signal that is represented with the help of M of T, and frequency of message signal we are writing FM. So here you will see that it is the sinusoidal waveform. So this M of T, we can have information like this: AM sine omega T. Okay, and this is the carrier signal, so that we represent with the help of C of T, so that we are writing AC cos, or we can take the sine also, so cos omega T. So generally here if you see that it is the sine, so we'll write AC sine, and omega is 2 pi f, so that is 2 pi f ct here, C for the carrier signal. Similarly, in the message signal, we have AM sine 2 pi FMT. FM means message signal frequency, FC means carrier signal frequency. So here FC will be much greater than FM. And this signal having information. Okay, message signal has information, so it is important. And this is the amplitude of the message signal that you are aware of that. And this is the wavelength, the difference between two crust or trough, that is the wavelength. And this is the from here to here is the time period of that message signal. So time period is duration of the one cycle, and number of repetitions, number of oscillation per second is the what we call as the frequency. That's why frequency will be equal to 1 upon T. And this is our carrier signal. So here you can see that period of this carrier signal is less. So that's why frequency is high. Here period of message signal is more, so that frequency is less. So you can see here that in one cycle of the message signal, how many times carrier signal is going to occur. So here it is taken example of the amplitude modulation. So in that carrier signal, amplitude is going to change according to instantaneous value of the message signal. Since name itself is the amplitude, so amplitude of carrier signal is going to change. This upper part is called as the envelope. Okay, how this signal is going to look on the basis of that. Similar envelope is drawn here. And here you can see that we have combination of AM plus AC. This is AC is the amplitude of the carrier signal. So maximum amplitude will go AM plus AC. So that is the maximum amplitude here. So first we'll draw the envelope here. Okay, on the basis of that, we are going to plot this information. So here this is our AM. Okay, in this AC is mixed, so this portion is AM by AC. Similarly, opposite side here. So finally, that carrier signal frequency is same, time period is same, only amplitude is changing. So here this is the negative one. So amplitude is less. Again, it is going to increase. Further, it is going to decrease. Since here negative amplitude is coming here, so like this, modulation takes place in case of AM. Later we'll see in details. So I'm not going in much depth. And another, if you see that we have different condition in the amplitude modulation on the basis of modulation index. That discussion also will be later. So when we have, this is the condition of 50% modulation, means this is the under modulation. When we have 100%, this is the perfect modulation. So here you observe this portion. Okay. In case of 150%, it is the over modulation. So that we have Ka is less than 1, Ka equal to 1, Ka is greater than 1. So here you can see that this crossover distortion takes place in this portion, and new envelope you are getting for this portion. So that all discussion will be in detail. Now here we have another type here in the linear modulation. This is the DSBSC. Here you can see the difference. This is the normal amplitude modulated way, this one, and this is the DSBSC where carriers is suppressed. DSBSC is the double sideband suppressed carrier. So where crossover distortion, all this we'll discuss. And another modulation is the frequency modulation. This is the part of angle modulation. Angle modulation having two types. One is the phase modulation, another is the frequency. So phase modulation and frequency modulation. That frequency modulation is called as the FM. So that is shown here. So here this is the message signal. This one is the carrier signal, and this is the modulated signal. So that modulated signal we represent with the help of S of t. So what you see here, amplitude of the carrier signal remains same, but time period is changing here. Okay. So here this is the signal is going to increase. So what you're saying, time period is going to increase. And here for the negative portion, okay. So when we have maximum amplitude, below this time period is less. Okay. So when we have again negative amplitude, here time period is more. Again, finally, so first it is the, like on the basis of message signal, it is like a compressing, expanding. Okay. So when we have less amplitude, it is more expanded, means time period is more. So frequency is less. When it is having high amplitude, time period is compressed one, that means frequency is more. So like this frequency modulation takes place. Here amplitude is constant, but frequency of this carrier signal is going to change. Whereas if you see in case of amplitude modulation, amplitude is changing, but time period of the carrier signal remain the same. So these are the discussion basics about what is the communication system, what is their blocks, and what is the modulation, what is the need of modulation, and just we have overview of different type of the modulation. Later we'll see in detail about AM, amplitude modulation with derivation, expressions, all these things we are going to see. Thank you very much. Like, share, subscribe.